I use mine as a bookmark.
I use him to help teach my class.
It's time for game plans.
And for a limited time offer, you can get yourself a Silly Man too.
The sample population is random or biased, polling any teacher's 5th hour about what kind of pizza they like. So random means fair, and biased means unfair or pushes you to lean towards one thing. Well, this one says any teacher with 5th hour or 5th period, there it is, 5th period, about what kind of pizza they like. Well, am I only selecting certain teachers, like males or females, or only teachers with the, I don't know, last name A, or older teachers versus younger teachers? And in this sample, you'll notice that, well, let me change my colors here. It is a random sample because I can ask any teacher. Number 3, identify which type of random sampling is used for the population. The first 50 people entering the zoo are asked if they support an increase in taxes to zoo expansion. So I wanted to underline it's the first 50 people into the zoo. Well, the first 50 people is really easy for me because maybe I just want to ask them, right? And then get into the zoo myself if they support increasing taxes. So a quick definition, clustering sample, is if I took all the schools in the district, Savannah, then CBA, and then say Magnolia High School, and I just pick one whole school, right? That would be a cluster sampling. And I don't pick CBA or Magnolia. The answer is a convenience sampling because it's really convenient for me just to ask the first 50 people in line. Random sampling would have been, let's say I got some people in line here. And let's say I would have taken every third person. So every third person, 3, 6, 9, counted by threes. That's called systematic sampling. Systematic sampling. To make it fair, it would have been random sampling. Question number 5, a researcher who wanted to determine the benefits of using a new algebra study technique obtained a permission from the school district to select 50 high school students. The researcher selected 50 algebra students at random. Okay, they're picked at random. The researcher selected 25 of these students to participate in the new study group. The researcher gave training sessions using the traditional study techniques to the other 25 students and asked them to use these methods. The most likely target population in this study is, well, let's say the first 25 are given the new study program. And here in blue, the second type is given the traditional. So 25 are going to the traditional, 25 is new. This is called an experiment. They're breaking them up in 2 groups and they're doing something to each of these groups. So this one, the question is asking most likely the target population. Who is the target population? Who are we trying to reach? Well, not all the algebra students in this study. Because the statistics, it's going from small to big. Because this is, if I chose just the 50 students, that's not just like, I'm trying to think of something bigger. That's what the point of statistics is, going from small to big. The answer is all the algebra students in the district. I want to talk about those 50, so that helps me make decisions for all the algebra students in the district. Which data set would you expect to have the lowest standard deviation? remember the conceptual understanding of standard deviation is that when you have numbers, you can do it by numbers, but conceptually standard deviation is a measure of spread. It's a measure of spread. Now the lowest, meaning little spread, like the butter and jam we've talked about, that means it's further away from the center. Further away from the center. Most of the data is further away from the center. Now this example B is a lot of the data is in the center, so that one has low spread. There's a center, and these have high spread, or high standard deviation because it's spread out. B has low. C has high spread because a lot of the data is towards the left and to the right, nothing in the middle. And same thing for D. So our answer is B. Now you can use this into a calculator. Put in my graphing calculator here. I'm going to press edit. I put in all my numbers into the list. And what I did here is, 18 means I have 3 of those, and I just that's called the frequency. So L1 is the number, L2 I put in the frequency or count, or how many of those numbers. There are 2 number 19s, or 2 X's at 19. So here that means, 21 has 1, 22, 23 has 1, 22 had 0, make sure to add a 0 there. 26 has 1, 27, there's 127, and there's 128. And then you can just go to calculate here. One variable statistics, the nice thing it tells you is where is the list of the numbers and then the frequency, the formula there for 1 bar stats, the very first one there. Again, this is using my graphing calc on my graphing calculator. When I click on 1 var stats here, I have list 1 comma list 2. So I press second 1, second 2, then enter. And then I'm looking for the population deviation, which is the sigma x 3.629, right above the N. And then there I just wrote, well, that was choice D. And then I did the population standard deviation for all of those, and you're just picking the lowest one. All right, to put this in Desmos, we're going to do capital letter X equals, you're going to do a bracket, not a parentheses. Put in your numbers, comma, no spaces. And you've done it correctly. You have 5 numbers on the list. If you see a triangle with an exclamation, it's wrong. And then now I'm going to do the population standard deviation. So keyboard, functions, go to statistics. If you needed to do the mean, you could do that. Capital X, and that's your answer. So if I wanted the population standard deviation, remember the difference between these two is this one has a P for the population, that means all, and this is just a sample. Capital X. Now, if you put an X there, notice it's wrong. It won't give you an answer. And then there, that's how you do it using Desmos. Okay, question 7a here says use the following set. Find the mean by hand. So the mean is X bar over the summation over the number in your list. So I'm adding up all of these numbers. And then I'm going to divide it by 1, 2, 3, 4, 5 numbers. And 100 divided by 5 equals 20. My mean is 20. Okay, now we need to find the standard deviation by hand. So I'm going to take my numbers in the list. 18, 19, 20, 21, 22. If it helps you, you can write down the formula. Standard deviation is equal to the square root of the summation of the numbers starting with 1. You take the numbers, we're going to subtract it from the mean, square it, and then divide our answer by n. Okay, so let's go ahead and subtract each of these numbers by the mean. So that'll be 18 minus 20 from above. Negative 2, negative 1, 0, 1, 2. Now I'm going to take each of these values and I'm going to square them. So we're taking the values, we just subtract it and squaring it. Okay, now I'm going to find the sum of all these values. So if I add all those other values up, that'll be 10. And now we're going to take the square root of 18, 19, 20, 21, 22. Stat, calculate one of our stats. Okay, so we add up all these values and you get 10. And our formula, it's divided by n, which is, we have 5 people. So that means you need to get the square root of 2. So our answer is going to be square root of 2. And so if you put that into your calculator, you'll get approximately 1.41 as your standard deviation. If you use technology like Desmos or graphing calculator, you'll recognize that your answer is 1.41.
Mr. Ang, I have a question. Do I have to divide by 0?
No, according to the 10 Commandments of Math, number 9, thou shalt not divide by 0.